I'd like to introduce you now to the person that you all came to listen to, Nick Donarski. A few notes about Nick that you may not know. He worked at both Trustwave and Hallock doing PCI audits early on in his career. He worked as a senior pen tester at Rapid7. He's a founding member of the HP Shadow Labs. He's performed critical technical roles at K2. He has professionally spoken on the security circuit at no less than 30-plus B-sides, DeepSec, Rocky Mountain InfoSec, Toronto Security Convention, and CanSec. He's certified and trained in ESI, Executive Security International, for those of you unaware, to be a physical executive protection expert. He's also cleared by the Department of State and certified to provide diplomatic security. One thing you might not know, in his spare time, he builds drones to use both in commercial and EMT environments. So without further ado, I'll turn it up to Nick to walk us through the demo of the Tagmata AI software.
Thanks, Ryan. Appreciate the great intro. Sounds like I'm a whole lot more special than I actually am. But yeah, I really appreciate the opportunity to present the Tagmata AI. I'm super excited for this. As soon as I can get the screen share, I'll share the screen. We can get the demo kicked off. But super excited about what this product and the project completely kind of entailed. This whole idea of bringing all these things together into one place stemmed from just a small problem that we ran into early on during an engagement, trying to figure out how to truly understand a network with all the various different vendors and all the different technologies, both virtual and classic hard technologies, and really trying to answer that question of how do we get the most amount of information in a single location and make it functional. So the first place that we're going to start is how the actual Tagmata AI ingests the information, really kind of starts that process. So the first part of the Tagmata AI is the data visualization and discovery analysis. And what we do is we start with a very simple, very classic style network map. And we can ingest this by taking Nmap data, Nessus information, and a whole number of other various vulnerability assessment tools in there. Or we can actually use the integrated network mapping utility. And what we do is we go through and we look at a network and we start to map where our endpoints are. Now, in all reality, this isn't the most fancy or the most bleeding edge technology thing out there, but we all have to start somewhere. So what we do is we start looking at the infrastructure at the endpoints. We start looking at what hosts are available, the types of systems, and we start mapping it at a very granular level. We can then take that information and we can see exactly what systems are where on the network, what's actually responding, what types of systems are out there, whether they're Windows, Linux, or switch, firewall, things like that, and just really get to a good understanding of what the network layout looks like. The next step is to actually take the information that most organizations don't even realize or don't even have an idea of how to visualize, and that's your VLANs, your VLANs, VDOMs, virtual network segmentation. And those are actually housed within your firewalls, your switches, and things like that. And up until now, the only answer to do that was to create a huge graph of an overabundance of tables and lines, and there was no real functional way to build that model. So what we did is we take that information and we're able to plug that into our DVDA. Here we can take a look and we've got a couple of VLANs set up. Here we've got a VLAN 1, VLAN 0, a security VLAN, and a couple of other items. We've got a VoIP VLAN and such. So if we actually go ahead and take a look at what the information looks like after we're able to collect it, we can start looking at, in this case, we'll look at our voice VLAN. Now, once we put in the information, we can start to see and start to build and start to understand better how our segmentation or what systems are dependent. So we can see that inside of our switch configuration, we've got a couple of systems that make up our VoIP system. So these VoIP connections are going to be the virtual connections that would be within one of your backbone switches. Now, in this case, we've got a couple of voice VLANs set up, and we can start to build our model dynamically. So if we want to see exactly what systems and what nodes are connected to each one of these VLANs, we can see where these nodes exist. Now, in the case of a VoIP system, these would generally be our voice IP phones or something similar to that. These could be conference systems or such. And these interconnections are all of the systems that are dependent upon within that infrastructure. Now, if we start to look and want to add further VLANs and get to have a really dynamic understanding of what our network looks like, now we can take this even a step further. Now we can see what endpoints are actually connected not only within our security VLAN, but also our VoIP VLANs. And by understanding where these interconnections are, where these sub-connections are, and where the configurations lie, we can start to actually dynamically understand, not only in the case of, say, incident response or breach, to see what type of threat vector or attack modeling would be able to be executed within those infrastructures, but we can also see what may be dependent systems. So in this case, we look at specifically a number of different VLANs that pull in a number of the different endpoints and the interactions between all of those dynamically. If you had to create a network model that looked like this type of an example or diagram, it would take a huge amount of effort, a huge amount of resources, and a lot of time to actually generate these maps. The beauty of it is that once we actually have all of these connections and all of the information coming in here dynamically, we can drill in and specifically pull out either connection strings or the amount of connections between hosts, and we can start to see some of this in the real-time world of our infrastructure. So leveraging things like the real-time agent, we can actually see whether devices are plugged in, unplugged, something's going down, even how much traffic overall. So the larger the line between two segments displays larger traffic flowing between that segment. Now, in these cases, this provides a huge amount of information, not only, again, from the incident response side, but we also have the architecture and development side, the research and development side, and the security ops. So we can take a look at very, very large enterprise networks and functionally make the data accessible very, very, very quickly. The next step, after we decided, okay, we've got all of this information, we've got all of the connections coming in to provide and collect all of the data from all of these different hosts. Well, what happens if we take that a step further? And what we begin to do is we start to look at the actual real-time data coming in. In this case, we're utilizing a number of IDS and IPS systems. In this example, we're using Suricata. And we also have a number of honeypot systems. We've got a couple of SSH systems, World Wide Web, honeypot, and a couple of other hosts that are actually collecting data for us. And these are real-time numbers. The beauty of the dashboard here is you can have a single repository for all of your information, whether it's specific events, whether it's a specific host. You can really dynamically drill down into this information as you see fit or as you need. So go ahead and take a look at the very top here. The first thing that we're looking at is an actual map of where all of our connections are coming in. We can drill down and actually zoom in to get a very, very deep level of information to figure out where exactly these connections are coming in from. The map will actually give you the latitude and longitude known based on the ISP information that it's able to collect. So if we go as close as we possibly can here in this graph, or in this map, we can probably get down to where we're able to see street signs and potentially all the way to where the actual connection is originating. Now, in the case of incident response, this is a huge benefit. If you can provide the detailed information to whether it be the FBI or police in the case of a breach, or leverage it for utilizing the analytics and the machine learning and building that machine learning model out to understand what may potentially be either detailed information, either the initiation of attack, or many other things that may come through. So we can actually see that this alert right here, which over the last 24 hours has 26,989 events, is coming from Warsaw, Poland. Now, again, this may be more of the high-level location or the ISP exit node, but it's a very good understanding as to where and when this information is coming in from. So you can actually leverage this throughout the various maps to look at detailed information, get a good understanding of where either your approved connections are coming from or illicit connections are coming from. You can utilize these types of geolocation and geo-IP information at a very, very dynamic level. The next thing that we're going to look at is we're going to look at the various different counters here. Now, the dashboard is very dynamic. You can drag and drop and replace these various widgets anywhere that you want. So it makes it very dynamic for whichever team is going to be leveraging it. There may be specific information that one user needs, but another user has no use for. The ability to build dynamic dashboards allows you to create an environment that, again, makes it the most functional information available. So here we can see that our SSH honeypot has had 61,031 events over the last 24 hours. And we can see that our Cowrie instance is actually the one that's seeing the most action over the last day. We can also drill much more granularly into the specifics of what's coming in, when it's coming in, and where it's coming in. Here's an example of a graph that specifically details what port traffic is coming in. And we can also see what types of hosts are being used to make these connections, where these events exist, and even a small list of understanding what country is hitting us at what point in time. Now, the beauty of this is that it's very dynamic. You can specify your specific moment in time based on as fast and real time as an update every 5 seconds over the last 15 minutes. We can also go to as far as back into the time scale as when the system came online. So the information that's detailed and stored within here can provide you not only incident response and DevOps and SecOps support from the time that it's being used, but can also go through the length and history of the time as well. A couple more widgets that we have built in here is utilizing our honeypot. We actually have the ability to create word clouds that show what's actually being supplied to our honeypot. In this case, this would be our usernames and our passwords here. And the larger the word, the more times it's showed up within our collection data. Same thing here with our Dianea honeypot. We can also see the types of connections over time. Here we can see that early on the 24th, that we had a very large spike of data coming from Poland. We can create histograms and datagrams that show just about anything that is able to be collected. We can show dynamic graphs, we can show static graphs, we can show a lot of different things. And this is where the one-size-fits-all really starts to show, because we're able to get all this information, which obviously fits all organizations, but the functional level or the benefit of being able to really understand that information is built in from the ground up. Here we can take a look at our specific IDS information coming in, and these are the types of attacks, especially the top 10 types of attacks that are coming in over our time frame. And we can see when they're coming in, what the point in time is that they're actually peaking, and we can correlate that to the specific information related to the ports, services, and connections coming in. Here we can also see the source information. So the IP address 195.22.126.166 has been our top offender over the last 24 hours. This IP address is part of the Sprint ISP. And we can also see what are the top 10 signatures that are actually kicking off the alerts. We can also click on the ID number and actually look at the emerging threat feed that's associated with that alert. So not only are you able to get the information provided to you, but you're also able to take that to the next step to have the understanding of what that really means. In this case, we're also showing the dynamic information related to how the information is collected or what's actually collected at each time. So if we look at this specific information, this alert was generated by our Dynea system. It was from Egypt here, and we can see the specific information coming from each one of these sublines. Now, the information is provided in JSON, which makes it very functional for also integrating other API data. So if you have a system or have a specific need, you can actually get the raw data coming in as well. So now, if we scroll back up to the top here, we can actually set our time frame to auto-update or include a specific period of time. We can look at, in my case, generally I'll look at the last 4 hours because that'll give us a good representation of incidents over time. And then we can also create an auto-refresh setting so that we're able to auto-refresh the information as quickly as 5 seconds. Now, in a live, real-world example, you may want that instantaneous information. In our example here, we're going to switch this to 60 seconds. So now, if we go ahead and look at the information after this refresh, we're able to see the specific information over the last 4 hours, and this will actually dynamically update as new information is published. So now we can see that over the last 4 hours, that our top offender is actually shifted, or we have other connections that are coming in from other areas around the globe. Again, we use those same histograms to see our moment in time and see exactly what's going on. In this case, say we wanted to focus in on this area right here, this time area, because we can see that we have a large spike. We can dynamically draw our box within this histogram, and after the refresh, it'll refresh all of your dashboard information from the map here through each one of the widgets and all the way down through each one of the dynamic dashboards. This is a huge benefit because now you can actually single out specific moments in time or specific attack vectors or a specific country that you want to learn more information. Now, as the system grows and as the system learns, it starts to understand what types of information is coming in and what's actually considered normal over time versus what might be a significant spike. Now, the machine learning framework that works in the background will notice these anomalies, and it'll actually generate a dynamic report specific to the fact that it has seen something that is abnormal. And these alerts can be issued via email, via Slack, or a couple of other specific reporting tools. And that can allow you at instantaneous moments to understand what's going on in your network at a much deeper level than, again, has ever been available to today. Now, integrating both the active and real-time management and monitoring and the DVDA, should a system have an anomaly alert, we can actually begin to highlight the specific area within the DVDA to see where that anomaly is taking place. Now, the benefit of that is actually being able to see and potentially predict what those threat chains or what the threat matrix may be for a system specifically in our network. So in our case, say we had this specific host right here, 192.168.16.149, that is compromised. we then can see that because it's on this specific VLAN, not only does it reside within this network, but these specific connections are trusted connections or known connections. And we can say, okay, well, if this area right here is the issue that, or is the affected area of the network, that potentially the threat vector or the threat map could expand through these systems. And if we need to take security precautions either on the switch or within the connections or down the chain to prevent that exposure to spread, we know where we can be actionable, and we know where we need to extend our time or our resources to help protect the organization and the network and the brand throughout the evolution of the network itself. So I really want to thank you guys for taking the time to go through just a very quick and very high-level understanding of what the Tagmata AI really is. Again, I want to say I'm super excited about this and the development and working with Atlantic to get this launched. At this time, I'm going to pass it back over to Ryan to close up for any words. But Ryan, thank you very, very much for bringing me on and letting me do this. And I really appreciate and look forward to talking to any of you guys in the future.
Thanks, Nick. Great demo, good walkthrough. If anybody has any questions, certainly reach out to Atlantic IT Group. You can see our information here on YouTube. You can ping us in a variety of ways, but the easiest is sales@atlanticitg.com. That's sales@atlanticitg.com. Thanks, everybody, for joining us today. Hopefully this has been a valuable use of your time, and we're open to discussions and evolutions of both your infrastructure and the product in the future. Take care, and thanks for joining us.